All right, so this lesson is 7.2, transformations of exponential functions. We've talked about exponential functions just in the last section. Of course, exponential functions are where we have y or f of x equals some constant to the power of x. So when the x is in the exponent position, that is an exponential function. X exponent, x exponent. We've also talked about transformations and the parameters. If we change the values for a, b, h, and k for other functions, we've seen how they've been stretched, they've been translated, right? And so we can apply all of these different parameters to an exponential function as well. So I'm going to head over to Desmos here somewhere. And this is, I just did this with the last group, so let's try and find exponential functions. Here we go. Started that yesterday, I guess. Okay, now, so an exponential function, as you can kind of see on the side here, y equals c to the power of x. If I vary c, well, let's light that up for, okay, so I've got y equals 2 to the x, and just so you can see that a bit better. So y equals 2 to the x, and if I have y equals 2.5 to the x in green, it's slightly different. If I change that c value, you can kind of see how this changes, including flips. Oh, I asked you guys a question yesterday, didn't I? What about the negative values for c? Why, if when I go to negative values here, why does nothing show up? Did anyone find the answer to that question? John?
I got it in class time.
You did? Okay, can you tell us what's the deal with the negative values here, why they're not showing up?
Because in the range, it says y is always bigger than 0. So
Yes.
if it's 0, like it can't be less than 0, which means if it's less than 0, there is no.
Okay. So in the textbook, the range. You said the range for the c value.
No, the y value.
The y value.
Yeah.
Okay, it has to be greater than 0.
Yeah.
Okay, so that's why it doesn't show up.
Yeah.
But what is it about the negative value of the c that causes a problem? So my question is, yeah, I know it's okay. So it says this in the textbook that we've got a problem. Why? I'm just trying to figure out why. So this is a bit of an aside here, right? Why does c have to be positive? Yes.
Because let's say we have negative number at power of 2.5.
Okay. So I'm just going to flesh this out. So you have a negative 2.5 as a base. Did you say?
That doesn't matter.
Okay.
And then power of 2.5.
Okay, and a power of 2.5. Okay.
Then we can write that down as
That would be negative 2.5 to the power of
25 over 10.
or 5 over 2. Good. Yes, we're getting very close to the problem now.
And then we can write that as root.
So this now becomes the what root?
Five.
Square root. The square root.
Or I don't remember that.
Square.
The one on the bottom is the index of the radical, or the root. So this is square root of negative 2.5. You see an issue there?
Of the power of 5.
Okay, of the power of 5 in there. Yeah, that's right. So we have a square root of a negative. No good. That is no good. So 2.5, this doesn't work. This is not allowed. This is no good. Here's my question, Hoon. Here's my question to you then. Thank you for, that is exactly where I wanted you to go. Here's my question though. If x changes, so at one point it's going to be 2.5, but at some point it's also going to be this. 5 over 3 as an exponent. So what is now wrong with this? Can you evaluate this? So this is a negative base, and I have an exponent here, and I'm taking the cube root of a negative number. Is that okay? Can I do that? Okay, let's just see. So the cubed root of negative 2.5. Oh. Can't do that. Non-real answer. Oh, I didn't put cube. Psych. Cube. Oh, let's start again. So negative, obviously square root doesn't work. Where was I there? Cube root number 4 of negative 2.5. We have a value. to the power of 5, I get a value.
Oh, and now it's negative. Why can't be negative? So that's how you.
So, but c is negative, so I do have a value here. So here's the thing. It's undefined with certain values of x, but it's defined with certain values of x. So is the fact that a graph doesn't show up if c is negative, does that mean that there are no points that exist? Okay, so because if it was negative 2.5 here, negative 2.5, okay, and I did have an x value of, let's just change this to what? 5 over 2 or 2.5? Undefined. That's undefined. But what about 5 over 3? Over 3? So that's here. So you have some x values that produce a point, but others that's undefined. Right? So where is the graph? Where can you see that graph? You can't see the graph because it's like almost every other point doesn't exist. Or there's lots of points that don't exist.
Would it exist if it was on, like the calculator was on plot points? Then would they show up?
If you were to plot, that's a good question. Yeah, you might have some points show up. You should have some points show up if it was just plotting individual points and not a continuous graph. Because it's not continuous, that's maybe why it wouldn't graph. But yeah, if you were to set it up to plot just points, you would obviously see some points. So we don't have a continuous function that we can kind of work with if c is negative. Okay? Does that make sense? So c can't be negative. So we're not going to, let's see, can I go back here? How far can I go back? X. There we go. Okay. Okay, so that's the answer to that question. Good job for thinking that through. Appreciate that. Okay, so that was a bit of an aside, a question from yesterday that we dealt with. Okay. What about a? The a value represents a what kind of stretch there?
Vertical?
Yeah, vertical stretch. Okay. So the a value represents a vertical stretch. So let's go back over to Desmos here, and let's take a look at where's a? Okay. So if a is just 1. Let's get rid of this. So if a is just 1, it's just 1 times 2 to the power of x. So I'm actually going to just put that in there so you can see that a bit better. And so if I move a, if a gets larger, you see how it kind of pulls upward? It's a little tough to see. It looks like it's kind of coming in this way, but it's actually stretching upward. Okay? Stretching upward. So with a value, as you increase a, it pulls up. If a gets smaller than 1, so that's 1 right there. If it gets smaller, it starts to get compressed down. Okay? A is still a vertical stretch. So as opposed to b, so remember that the b value, let's go back to that b value real quick. Where is that? Okay, so let's make b just 1. There we go, 1. And the b value gets larger. You see how it compresses in towards the y-axis, right? So we have, see it pulls in this way towards the y, and it pulls in this way towards the y. That's a different move, that's a different look, right, than the a. So once again, let me see if I can do this both at the same time. So here's the a, see it gets pulled upwards. That's the a, pulling upwards. And the b gets compressed inwards and outwards. So the b gets compressed inwards. All right? Questions? So for the b, the negative b value flips the graph about the y-axis, and the horizontal stretch is a 1 over b. So with the a value, as the a gets larger, the amplitude gets bigger. with the b value, as the b value gets larger, it actually compresses in this way. It's kind of an opposite. So it's 1 over the absolute value of b. Okay, so let's take a look at C then. Well, I guess I don't have a section pre-made for C. So let's do C down here. Or sorry, H. We use C as the base. So H. Okay, so what happens to H? Do you remember what H was for the other transformations? It was?
Moving like horizontal.
Yep, horizontal shift or translation along X direction, right? So it's in with the X there. That represents the horizontal shift. Okay, so let's take a look at. So here's 2 to the power of x minus h. So as h gets larger, it's x minus 1. So there we go. It kind of moves. Now that's not stretching. That's actually moving. It looks kind of weird, but you see it's just moving left and right. It kind of looks like a stretch here, doesn't it? Kind of looks like maybe a compression. It looks like a. So it's tricky. It's tricky. You have to be very careful to decide whether this is an A value compression or a C value movement. What you'd want to do is you'd want to compare values on this graph and the Y value right beneath that, and do that a couple times to see if it follows the same pattern. So see if this graph right here would be a compression in the vertical, because they should have the same factor, right? Times the same number to get down there. If that doesn't hold true, then what you do is look horizontally, and you say, okay, there's 0, 1. Now here is sorry, here is can't quite get it. But anyways, it's a move of almost 2, right? And so this one right here, this point, horizontally would move the exact same. This point, move the exact same over. This point, move the exact same over. So when those line up, you know it's a translation. Questions? Is this pretty easy stuff for you, because you've seen this before in other functions, right? Okay, pretty straightforward. All right, well, let's just talk about the last one then, k. Okay, so if we have a k value of 0, we have a function that's exactly the same as 2 to the power of x. But as we increase k, what happens is it moves everything up. So this is a vertical translation, up and down. Okay. So k is a vertical translation. And if you have plus k, means moving graph upward. Negative k moves down k units. Okay? And maybe we need to make that note on H2 about how it moves. So let's just do that. So horizontal shift, right? If we have x minus h, means h units to the which direction? Right. X plus h means h units left. So that it's sort of opposite world right there, right? Awesome. So I'm just going to revisit the mapping notation. If you have an original graph that is x, y, the parameters a, b, h, and k then can be applied to the x value this way. So it would be x divided by b. So any x value in the original graph, you would divide that by b to get, a new x value, and then you would add h. Boom. That's the image point, or the image x value there. So divided by b, add h, sorry. And then for the y value, you would multiply times a. So any y value, you'd multiply times a, and then you'd add k. and those two together would be the new point. Okay, so this is the mapping notation. So let's say for a certain function, let's just make one up here. So y equals 2 times 2 to the power of x plus 1 minus 7. So if this is our function here, we can identify a as 2, b is what? 1, h is actually negative 1, yeah, and k is negative 7. So if we have those values, we can plug any given point, okay? So let's say we have on the original y equals 2 to the x, right? Let's say we have 1, 2. So if we have 1 comma 2 on the original, the image point for that point will move to this. It will go, 1 divided by b, which is 1, plus h, which is negative 1. That's going to be your new x value. The new y value will be the y value, which was 2, times a, which is 2, and then plus k, which is negative 7. So we'll have 1 minus 1, which would be, looks like 0, and then we'll have 4 minus 7, negative 3. And of course we could, we could certainly see if that is true. So x being 0, we could plug in 0 in for x and see if that's what we get for y. That's one way we could check to see if that's true. So let's check it out. Y equals 2 times 2 to the power of x is 0. So y equals, well, 2 to the 1 is 2 times 2 is 4 minus 7 is negative 3. That's true. Okay? So the mapping notation, if you're just asked for a single image point, you don't have to transform and sketch the whole graph and then find out what that point is. You can just use mapping notation. All right? So you can, so that's the mapping notation. You guys remember that? Okay? Sort of? Okay. All right, I'll just do one more thing with you here from the textbook. Let's take a look at number 4, question number 4 on your assignment. Let's do a little matching here. Okay, so if we take a look at 4a, all right, this says, without using technology, match each graph with the corresponding function. So let's just take a look at this. We have, excuse me, we have what appears to be an exponential function that's been flipped, right? It appears that it's been flipped a number of times. It appears that, and again, what I'll do is I'll just clip this into the notes. Let's bring that over. So this is what I'm seeing with this one. It looks like that it has come from, a flip like this, right? And then maybe again a flip like this. So that red one looks more like the actual exponential function, right? So I think we've got a double flip here, which means what? That a is going to be negative something, and b is going to be negative something. Does that make sense? Okay. So that's where you could start. This graph has been moved up. It appears 2 units. This little dotted line means that we've got a horizontal asymptote, which should be the 0, right? So what does that tell us? Does that talk about k? So does k look like it's going to be 2 units? Maybe? Okay. What about h? Can we tell if h has where h is? Well, this original graph, if this was x, or the original graph here, right, it should be up 1 unit from the horizontal at 0. So from the horizontal asymptote, this appears to be 1 unit away. So we might not be dealing with any kind of shift here, right? So it could be true that this could be 0. Now A, we're not really sure actually about A and B yet, but this is a matching question. So that means that there should be some options in the textbook for us to look at. So we can try and piece some things together. So which one of these appears to possibly have some of these characteristics? So we've got a flip. So it looks like A is going to be negative. Okay. So maybe C or D. Do we have anything else that looks familiar here? Oh, I have one with a base greater than 1 and one with a base less than 1. So what does that do again? Greater than 1 looks like this. Less than 1. Okay, so that could be this flip here could be the constant, right? Being less than 1. That's okay. So we have a +2 on both of these. So does it look like it could be C? Okay. So I think if we put everything together here, this could be it. So what you could do right now in your graphing calculator is type C in and see if it matches the graph from A. So go ahead and do that. So type this C into your graphing calculator, into the y equals, and see if it matches. So yeah, you'll notice that we talked about a negative b value. Well, a negative b value actually does flip the graph as well. So negative b could be negative b, or it could be a c value right here between 0 and 1. So they both represent this sort of a flip. Yeah. So does it match up? Does it match up with your graph there? Okay. So yeah, so with that one looks like C then. So C is A. All right, any final questions? Okay, so just so you guys know, the key ideas at the end of the section there, you take a look at those. It's a summary for everything we've talked about in our lesson today. So if there's anything in there that you don't understand or you think that I missed, let me know. Can explain that for you, but that's just before your homework questions. So again, there's your homework questions, 7.2, and I'll just show you the pages of the textbook here too, in case you're at home watching this video and you don't have your textbook on you.